Hey everyone, today we're going to discuss about the mean, variance, and standard deviation of a discrete probability distribution. So in order for us to analyze further the data contained in the discrete probability distribution, we can obtain the mean, the variance, and the standard deviation. The mean, which is also called the expected value, it tells us the expected outcome of the random variable if the experiment is done repeatedly. While the standard deviation, it indicates how far or how close is an observed value from the mean. So this tells us that if the standard deviation is low, then any value of the random variable would be expected to be close to the mean. While if the standard deviation is high, then we would expect that any value of the random variable would be somehow farther from the mean. In order for us to solve for the mean, variance, and standard deviation, we make use of certain formulas. For the mean, indicated by this Greek letter mu, this is equal to the summation of the expected value x times the probability of x. So what we just do is we multiply the value of x and its probability, then we add all them up, indicated by this summation symbol. So that is the mean of the discrete probability distribution. For the variance, this is indicated by sigma squared. This is Greek letter sigma. This is equal to the summation of the square of the scores times their probability. Then add them all up, then subtract it with the square of the mean. So basically, we take the score, we square it, we multiply it with the probability, then we add all them up, then subtract it with the mean. So in order for us to get the variance, we have to obtain the mean first. And remember, in our statistics, the standard deviation is just simply the square root of the variance. So the standard deviation, we just take the variance and get the square root. So if you observe, the radicand part of the standard deviation is actually the variance. Okay, let's have an example here. So let's have a table. This is a probability distribution x whose values of x's are 3, 2, 1, and 0, while their probabilities are 1/8, 3/8, 3/8, and 1/8 respectively. Let's obtain the mean, the variance, and the standard deviation of this discrete probability distribution. Okay, so what we can do here first is that we can add more columns to the table. So we have x and we have p of x. If we want to obtain the mean, we have to add another column which indicates the x times p of x. So let's do that. So let's insert 3 columns here. Then we'll just copy the x and the p of x. This column here is x times p of x. Okay, so we will multiply x and p of x. It's better if we can write the fraction parts into decimal so that we won't be having a hard time on multiplying the x and the p of x. So let's convert the 1/8, that's 0.125, and 3/8, 0.125 here, and the 3/8 would be 3 divided by 8, 0.375. So let's multiply the x and the p of x. So let's multiply 3 times 0.125. So that is 0.375. Well, for the next one, we have 0.375 times 2, 0.75. Well, for the one here, 1 times 0.375, 1 times 0.375, that is 0.375 as well. And for the last one, 0 times 0.125, that would be 0. So after this, let's add all this x times p of x so that we can get the summation of x times p of x. So this is summation of x times p of x is equal to, let's add them all up, 0.375 plus 0.775 plus 0.375 plus 0 is equal to 1.5. Therefore, the mean of this probability distribution is 1.5. Therefore, mean is equal to 1.5. So that would be the value of our mean. Now let's compute for the variance, then for the standard deviation. So for the standard deviation, we're going to need two columns. The first, 4 columns rather. So this is the first 2 columns. After that, we can add the x squared column, then the x squared times p of x column. Okay, so let's have the standard deviation. Let's add more column here to the right. And let's convert this p of x's into their corresponding decimals. So this becomes 0.125. This is 0.375. I'm just referring to what we just did earlier, okay? So this is 0.375 and this is 0.125. So for this column, we are going to have the x squared column. And for this column here, we'll have x squared times p of x. So let's square the x's first, then we multiply it with the probabilities, then afterwards we add them up. So why do we add the last one? Because it's indicated here. It's the sigma. That's the summation symbol. So let's get the square. 3 squared is 9. 2 squared is 4. 1 squared is 1. 0 squared is 0. Then let's multiply the x squared with this probability. So that would be 9 times 0.125. That's equal to 1.125. Well, for the next one, we have 4 times 0.375. That is 1.5. For the next one, we'll have 0.375 times 1, which is 0.375. And the last one is 0.125 times 0, which is obviously 0. Then after that, let's add them all up. So, yeah. So the sum of this expression here is 1.125 plus 1.5 plus 0.375, that's equal to 3. Therefore, the variance would be, remember that it is this symbol minus the square of the mean. And remember, the sum of x squared minus p times x is 3. So this will become 3. So let's rewrite again the variance. So this is the variance. Then after this, where is it? So sigma is equal to, remember that this x squared times p of x is equal to 3 minus their mean is 1.5. So that is 1.5 squared. So let's solve for that. I forgot the square symbol here. So there. So sigma squared, that's equal to 3 times 1.5 squared. So let's solve for the 1.5 squared. So the 3 times 1.5 squared is 2.25. So this is equal to sigma squared is equal to 3 times 2.25, that is 0.75. So the variance would be equal to 0.75. And we can solve for the standard deviation by just taking the square root of the variance. So the standard deviation is the square root of 0.75. And this is equal to, the square root of 0.75 is 0.866 something. So let's just round it off as 0.87. Let's have it two decimal place. So 0.866, so that's 0.87. If you can observe here that the standard deviation 0.87, so it's a bit lower, small. So we can expect that in a given random variable, the value of the random variable would be somehow closer to the mean, which is equal to 1.5. So this is how we obtain the mean and the standard deviation of in any random variable. So for our next video, we're going to tackle real life word problems involving the discrete probability distribution. So I hope you guys learned a lot today. Thank you guys for watching and see you guys in the next video.